Think about the Mona Lisa, Beethoven's 7th Symphony, the light bulb, and much more. All of these shape our lives and are a result of human creativity, and yet, even in the scientific literature, there is no clear definition of what creativity is. Luckily, this unclarity did not hold researchers from exploring the field of computational creativity. The two concepts of machine and creativity don't seem to work together at first thought. A machine is doing precise calculations and works in a predictable way, while creativity is not even fully understood. Nevertheless, AIs have already produced images, songs, and even simple languages. And although we don't have a full and clear definition, we do expect the creative process to include some characteristics. These include thinking outside the box, flexibility, novelty, analogy, self-improvement, human emotions, aesthetics, and autonomy. The last three are particularly interesting. The need to include human emotions shows two things. First, we want a proof that the machine is not just another computer program. Second, we expect the computer's creativity to mimic, at least in some way, human creativity. We can see this as bravery and curiosity are the most common emotions, and the two play a major role in human creativity. The requirement for the machine to judge the quality and discern good artifacts from bad ones is more than reasonable. In the creative process, there are many creations that do not hold up to the standards we want them to. As humans, we have ourselves and others to do this quality check, and we still want machines to show us much less banal creations than we show ourselves. Not by chance, alongside research that aims to produce creative art, music, poetry, and more, there is extensive research and ongoing progress in evaluating of machines their own creations. And lastly, autonomy, the independent thought and lack of predefined rules. This is the top priority among skeptical who question computational creativity. But how can a machine be autonomous? It's difficult to give the credit for their creativity to the machine, and not its creators. This is because, unlike humans who learn from their parents and teachers, the programmer not only teaches the machine, but also architectures the way it thinks. However, despite the full control the programmer has, not always the final program can be explained. For example, a vital part of the way a neural network behaves is the amounts of influence of neurons on one another. These are determined when training the network, and in many cases are not understood afterwards. So, a good criterion for autonomy might be exceeding the intent of the programmers or creating something they could not. But before we try evaluating and measuring creativity, we must remember that we imagine creativity with respect to the world we perceive. And this leads to two problems. One, our world is, frankly, very complicated, and getting a computer to comprehend it is out of our current ability. We need to acknowledge this, and to get to our goal, we should go step by step and look at the artifacts as an output of the world perceived by the machine, which is its input. 2. If we test and measure the creativity of any system, we risk constraining it to what we think to be creative. To tackle this, we can ask for the ability to explain the acts and decisions from the machine. Not only will it help understand the machine's intentions and back up the artifacts, but also be a creative output of its own. The field of computational creativity has far more to it. From researching the deep structures and implementing them, creating systems designed for co-creativity with humans, to building steadier foundations for future research, if you look even briefly on the recent developments, you'll find that a lot of creative minds are working on creating the next creative mind.